mathematical is height to compare the work done and the power developed by it.
We are doing question 6. Question 6 is very similar to question 2. What are we supposed to do here? Compare the work and power. What is given here? Mass is 50 kg. It is the same box. All this, what is your to do yourself? Anybody requires pen, just walk and press the button. Will we start? Oh yeah. Focus here, focus here. You won't feel. ठंडा लगेगा कि गरम लगेगा. So what is given here? 50 kg mass. Height given is 2 meters. And time is 2 minutes. And it is the same height. 2 minutes and 5 minutes. 3 1 is. T2 is 5. That's it. So 1 and 2 represent here, man 1 and man 2. Okay, 2 different mans. Now we have to do the work comparison. What is W1 by W2? Correct? W1 will be mgh1 divided by mg. What is going on at the back? Okay. W1 by W2. सेम मास उठा रहा है. हाइट कितना सेम है कि अलग है? Height is also same, right? So height will be same here. So work done will be 1:1. Because it is given same mass lifted by 2 persons, 1 and 2 by the same height. Okay, mgh by mgh. So it is W1. So W2 is equal to 1:1. Then the power developed by them. P1 by P2. What it will be? W2 by P2. This is so W1 by W2 we got 1 by 1. And T2 is 5. Now no need to change the units here because it's ratio, so they will get cancelled. Okay, so the answer will be 5:2. Comparison questions, you have to take the ratio and read the question carefully so you know that it's the same value, right? MGH by MGH. So seventh question, we will be able to do till seventh question so far because we have discussed the theory only till here. Okay, after that we'll have to go to the next topic. ठीक है, एनर्जी का थोड़ा और डिटेल में पढ़ना पड़ेगा, then only you can answer. Okay. Question.
An ox can apply a maximum force of 1000 Newton. It is taking part in a
Kart race.
And is able to pull the cart at a constant speed of 30 meters per second while making its best effort. Calculate the power developed by the ox.
So it is a straightforward formula. Which formula? Force into velocity. Only two things are given. So force is 1000 Newton. Velocity is 30 meters per second. So this is 30,000 watt for 30 kilowatt. So from the given data, you can figure out what formula is to be used. We have pretty much covered all types of questions. How many of you are following Selena? Quite a few. So unit A of Selena is done, right? Likewise, the basic work, power, energy questions are done. Now we will get into different forms of energy. Okay. Can I start? So different forms of energy. So tell me what are the different forms of energy? In 9th standard you have got. Would you like to tell different forms of energy that you are familiar with? Kinetic energy. That is a category of mechanical energy. So let's start from start. There are seven. Okay. 7 forms of energy. What is the main source of energy? Sun. So the first source of energy is light. Think of life evolution, right? Without sun, no energy is possible. What is the second form of energy? So when a child is born, he cries. Sound. Sound is the next form. So let's go with evolution. Sound energy. Then you start moving, right? Mechanical energy, motion. Mechanical energy is associated with motion. Motion or rest. Mechanical energy is associated with motion or rest. So it has two parts. The energy associated with motion is kinetic. And energy associated with rest is potential. So sum total of kinetic and potential energy is called mechanical energy. Then you will need something to eat. So how you will cook food? Need energy. Everything is pretty logical, okay? Heat energy. How do you get heat? By burning something, which is chemical energy. The process of burning is a chemical reaction. So this is chemical energy. Right? So chemical energy से हमको क्या मिलता है? There are two types of chemical reaction, exothermic and endothermic. So heat is produced by exothermic chemical reaction, right? Then what else? Now heat is still primitive, right? When you are burning coal or wood to get heat. Now how do we produce heat? An electric oven. What is it? Still we use CNG gas, etc. or LPG or what else? Liquefied petroleum. घर में आता है वो क्या आता है? CNG आता है ना? Compressed natural gas, right? So that is still chemical energy. Wherever we are burning, okay, that is still chemical energy. We also have electrical energy now. So most modern form of energy today is electrical energy, right? All the energy that we are using today, mostly it is in the form of electricity, and then we are converting. Like how many conversions we are seeing here? Electrical to light, electrical to mechanical, electrical to heat. Okay, is it not heat energy? It is extracting heat and throwing out. If it was a cold country, it will extract warmth and pump in heat inside. So heater or air conditioner, these are heating only. Okay. Then the latest is nuclear energy. All right, sit down. So these are basic forms of energy. Only these 7 basic forms as of now. All other forms are derivatives of this one. Okay. Now the entire energy of the universe is, let's say, 100%. So that is fixed. The energy of the universe is fixed, and it is available in one of these forms or mix of these. Right? What we do is we have actually manufactured devices which convert form of energy into other form. Whenever we use or work with devices, basically what we are doing is we are converting one form of energy into other form. Like if you are using fan, what are you doing? Electrical to mechanical and heat. Okay, electrical to mechanical to heat. Right? So this is what we'll be doing. Now in this chapter, we'll focus everything on mechanical energy. We are only going to learn about mechanical energy. The rest of the physics course is about learning the other form of energy. You can check the index of your book. You'll be studying about light, sound, heat. Chemical will be taught to you exclusively in chemistry. Okay? Electrical and nuclear. In modern physics, the last chapter will be studying about nuclear energy as well. Understood? So physics is all nothing but study about energy and its application. That's what is physics in short. Understood? तो सारे chapter तुम्हारे एक एक energy के ऊपर ही है. That's why this chapter is very important. It sets the foundation for further learning. Okay? And all the units that you are learning here will be used in later chapters. Okay? Now, so let's explore mechanical energy. So what is mechanical energy? Write down. Write these things, and then in this chapter we are only going to explore it further. Okay? So first write this and then mechanical energy. Let's take Okay. So let me explain observation of energy. Then that question will not exist. Yes, by observation of energy. Potential energy is equal to static energy is equal to. Okay, shall I state mechanical energy? Write down. It is the sum of kinetic and potential energy. Whose mechanical energy? Total mechanical energy of any body. Total mechanical energies of any body. Is sum of its kinetic and potential energies. So for any body, mechanical energy of any body is sum of its kinetic and potential energy. Okay, that is total mechanical energy of the body is equal to A plus U. So where E is total mechanical energy. A is kinetic energy. U is potential. Right? So this is what we are going to learn. Let's start with potential. First, we'll learn about potential. Symbol is U. Write down. Write about potential energy. Potential energy is the energy associated with the particle. The energy associated with the body. By virtue of its change of position. By virtue of its change of position or of configuration. Or of configuration. Change of position or of configuration. Configuration means shape and size. Body's configuration is changed means its shape or size has changed. What did you write? Anybody read whatever it is? Change of position. Okay. Now, energy associated with the body at rest here. At rest. Okay. Body here, energy associated with the body at rest. Okay. So we are saying potential energy. What is the meaning of potential? So which it is still not realized. The body is having energy which is stored in. Okay. So how the energy will come? How does body gain energy? Concept. How a body gains energy? When work is done on the body. Correct? For any body to gain potential energy, somebody has to work on the body. Got it? Now, so potential energy is used in different contexts. What we will learn in this chapter is gravitational potential energy. Okay. Specifically, there is electric potential. Okay, there is elastic potential. Right now, we are going to learn about gravitational potential. Right? Now, imagine this is the surface of Earth. My palm is the surface of Earth. And there is some object lying. Does it have any energy right now? When it is lying on the surface. Let's say it is hammer. What is it? Hammer. Now when I raise it, have I walked on it? How much work I have done? mgh. So how much energy it got now? mgh. So when the hammer was lying on the ground, it had zero potential energy. Now it is at rest right now and zero potential energy. Now I raised it by height h. How much energy it has got? mgh. Is it at rest? Yes. Is it not at rest? Yeah. So it is now having potential energy mgh. Now imagine there is a nail. Let's say this is a wooden plank. Now a raised hammer, when it is dropped, will it be able to displace the nail into the wooden plank? That means it did work. So when it has energy, right? When it is dropped, it will transfer its energy on the nail. That nail will be pushed into the wooden plank. Got it? So it gained energy when I raised it. When it is dropped, then this body worked. Got it? And repeated lifting and so hammering. So constant work is being done on this object, and this object is also doing work. You get it? You get it? So this is potential energy. And why are we calling it gravitational potential energy? Because if there was no gravity pulling it, we are doing work against gravity. So whatever work we are doing against certain kind of force, then only potential energy of that nature will be stored there. Get it? Just like if you had a spring, okay? Now a spring is in a relaxed state, then it has no energy, right? Or take the example of bow and arrow. When the bow has got a string, when it is relaxed, right? It can't throw the arrow. Now when you pull the string along with the arrow, so there is elastic potential energy now in the stretched string. Why so? Because when you stretch the string, that's when it develops restoring force. So you're stretching the string against some kind of force. Just like when you lifted the object against gravitational force. Okay? So the stretched string will have what kind of energy? Elastic potential energy. Now when you release it, just like when you release the hammer, it will drop. Here it will roll the object which is stretched along with the string. Okay, this is the principle on which the guns work. So if you pull the trigger, actually you are pulling the spring. The spring has got no elastic potential energy. When you release the trigger, it will hit the loaded bullet. The bullet just flies up. Okay, understood? So this is how. What is gravitational potential energy? So the expression for gravitational potential energy is how much? It is equal to work done on the object against gravity. Okay, so gravitational potential energy is nothing but it is equal to work done on the object against gravity. So this is nothing but how much is this? It will be mgh. So this is the expression for gravitational potential energy. So energy is also what? Whose work is appearing as potential energy? The one who is lifting object against gravity. So it has to be positive. So gravity is doing negative work. But whose work done? The one who lifted. Who is lifting the hammer? Gravity? The person lifting the hammer. So उसने जो work किया, that is positive. They exerted force in the upward direction. The hammer moved also in the upward direction. So work done is positive. Clear? So this is the example of potential energy in a scenario when the position of the object is changed from ground. Let's say this was position A. Okay. So from position A to position B, position is changed. And at both the places, the object was at rest. Right? What is the potential energy at the ground? 0, because H is 0. What is the potential energy at height H? At this place? mgh. Clear? Okay. This change in potential energy. Question: what is the change in potential energy of the object when it is taken from B to C? So what is the potential energy here? What is the potential energy here? The potential energy of the object is always with respect to ground. Okay. So what is the change? Yes. That is. So this is the change in potential energy in going from B to C. So what is it? It's a change in potential energy. Understood how to calculate change in potential energy. So it matters only on height, vertical height. Okay. our concept, if the object was not lifted straight, let us say it was taken through a step, then what is the potential energy? Let us say this is equal to mgh. Let us say this object was taken like this. Okay. The object was taken like this, and finally it reached here. What is the potential energy? Here the position A is here and B is here. What would be potential energy when the object is taken to this position? Will it be same or different? Huh? Same. It is gravitational potential energy, right? So what is the idea? This H only. You have to always consider the vertical height, irrespective of how the object was raised. The displacement or vertical height with respect to ground. So here also U will be mgh only. If it was a slope, let us say object was taken like this, will it matter? No. So for calculation of potential energy, what you need is only vertical height from the ground. It does not matter how the object was raised. Okay. So this is what is potential energy. So we covered gravitational potential energy. Next is elastic potential energy. Are you done writing this? Done writing this? Erase it. This is elastic potential energy. Let us say you have a bow and arrow. So let us say this is the bow and you have arrow kept here. Now the spring is stretched. Right? So when the spring is stretched, that is when it will have elastic potential energy. Okay. Now when the spring is released, it will go to its normal shape. So what is changed here? The shape has changed. So it is the case of change of configuration. Whenever you change the shape of the object, elastic object, it would try to restore when the external force is withdrawn. Just like the hammer will try to come back to ground when the external force is released. It will drop down. So you are only making an effort in lifting it. Down you are just dropping. Okay? So that's what happens. Okay. is stored in stress state. Likewise, if you have a spring, this is a relaxed spring. Right? So this is a compressed spring. So compressed spring now has stored elastic potential. Because whenever you change the shape of the spring, the restoring force will develop in the opposite direction against the external force, which will restore its shape. Now, when you change the shape, you did it gradually, but when you release, it will happen suddenly. Okay, so the impact, the force generated by the spring release will be very high. When the impact is high, when the rate of change of momentum is high, that is delta T small. When you release the spring, the spring will go back to its original shape in a very short time interval. So the force generated will be very high. Okay, that's why the bullet goes so far. You get it? Because trigger, when you release the trigger, it releases suddenly. The delta T is very short. And when you are loading it, then you are taking much more time. So your effort is also less because you are applying it over a large time interval. Okay, so the effort to load the gun is small, but the force that you get it is much more because delta T is small. Got it? So here if you had kept a ball here, so when you release it, okay, when you release it, it will fly off. Okay? So is the concept of potential energy clear? The concept of potential energy clear? How do we get potential energy? By, by working on an object against certain kind of force. What two forces we saw here? Gravitational and elastic force. Elastic force in case of spring and spring. Okay. And it is also potential because it is still waiting for action. It is stored as long as it is under the influence of external force. That's why it is potential. The moment you release the external force, that's how the potential energy will come into action. And then it will be called as kinetic energy. And the potential energy converts, it converts into kinetic energy because it produces motion. Now let's see. So therefore now we'll learn what is called as kinetic energy. Its symbol is K. Write down. Let's write kinetic energy. Everybody is ready? Kinetic energy. It is the energy possessed is the energy possessed by a body by virtue of its motion. Is the energy possessed by a body by virtue of its motion. As simple as that. So, when do we say that a body has energy? When it is capable of doing work. Okay, any body will be said to possess energy when it is capable of doing work. Is a moving body capable of doing work? Is a moving body capable of doing work? What do I mean by capable of doing work? Huh? It is kinetic energy now. When a body is capable of doing work, what is work done? Force into. So work done should consist of two things. There should be force applied and there should be displacement on whichever body it is applied. So let's say somebody is standing here. Okay? And one of your friends who is running very fast hits you. Will you remain standing there? Where will you go? You will be displaced in the direction in which your friend was running. So a running body is capable of applying force as well as causing displacement. That's how work is done. Okay, understood? So any object which is running, when it hits any other object or collides with any other object, it will displace that object. And during collision, it will transfer its energy into that object. Is it clear? So this is what is kinetic energy. So we have to now prove that it is given as half mv square. Okay, we have to show that kinetic energy of the body is given as half mv square. So how to derive? How did we derive potential energy? In terms of work done. Likewise, what is kinetic energy of the body? Yes. What is kinetic energy of the body? You change your place. Come here. Come here. Come fast. उठ गया पहले. अरे चुप. Okay. So a body in motion, was it in motion forever? Before motion, it must have been at rest. तो किसी ने तो उसको मूव किया होगा ना, ठीक है? So kinetic energy possessed by a body must be equal to work done on the body to change its speed from 0 to whatever speed it is at. Correct? So it is equal to work done on the body to change its speed or velocity level of u to v. This u, if the body was at rest, would be 0. So body could be moving also initially, or it could be at rest, like a football, right? So it was moving at a low speed. Then somebody kicks it, it moves at a fast speed. So initial kinetic energy will be less. Now it has more energy. Or if the football was initially at rest, like the goalkeeper, so it has no kinetic energy. Now the goalkeeper hits it. Now it has kinetic energy with speed v or velocity v. Correct? So with this, now we'll derive this expression. So let's say you had an object of mass m. Initially, let's say its speed was 0. Now, how will it get speed? Somebody will have to kick it or apply force. So when the force is applied, पीछे देखेगा ही नहीं, इस बार पीछे देगा तो बाहर, और साथ में जो भी बुला रहा है उसको देखना मत, पीछे नहीं कोई जाएगा वहां, ठीक है. This object was initially at rest. अभी if we apply force, obviously it will be accelerated. Application of force means there is acceleration. Acceleration means its velocity will change. So let's say force was applied in displacement s, and out here its velocity becomes v. So force was applied in displacement s. जब उसका velocity v हो गया तो force हटा लिया. So now the body is moving with velocity v. No force, no acceleration, uniform velocity. Correct? तो अब इसको कैसे लिखेंगे? What is the work done? Let's say this is equation 1. So what is the work done? In this case, work done is map into s because displacement is in the direction of force. Okay. Now, therefore, W is equal to what is F? Mass into acceleration by Newton's second law. And S is by third equation of motion. V square minus U square by 2A. Correct? So this is final velocity, initial velocity divided by 2A. Because V square minus U square is equal to 2AS. So S is equal to V square minus U square by 2A. Right? Everybody understands this step? So what do we get? So A cancelled. Okay. So if initially body was at rest, U will be 0. What do we get? If initially the body was at rest, U is equal to 0. Therefore, W is equal to half U square. So from 1 and 2, what is K? Okay. So we can always measure energy in terms of work done on the body. Energy possessed by the body is always equal to work done on the body. So in this equation, we get work changing its speed from 0 to E. Okay. So if this is the expression for kinetic energy, then we can call this as final kinetic energy, this as initial kinetic energy, right? Also, this is called work energy theorem. So work in general, work done on a body is equal to change in its kinetic energy. Okay. So W is equal to delta Q. This is called work energy theorem. very important concept. Work done of the body is equal to maintenance standing. Work done of the body is equal to change in its idea. Where it came from here. Basic concept is very simple. It's the interpretation and application. That's where it's a clear here. Final kinetic energy, which is half mv square, because v is final velocity. And what is ki? Initial kinetic energy, which is half mvu square. So this is a more general formula. Okay. Where if the initial object was not at rest, then you can calculate or use work energy here. Clear? So check, brothers. This work energy term here. Elena, it is. Do we have clear work energy here? Right. Read what is given there. Are you able to understand? Correlate it with what I just discussed. That's it. This is the only concept. Now we'll discuss conversion of potential energy to kinetic energy. So anybody requires any more explanation here? Here? All understood? Okay. So rest will become clear when we solve numericals. Okay? So the stored energy is potential energy. Whenever conversion of energy happens, always potential energy is first converted into kinetic energy. Okay, the first conversion is from potential to kinetic, and then into any other form of energy. Is that clear? Like you are familiar with idle power plants during hydroelectricity generation. So can you explain the energy conversion taking place via idle power? Idle power plant, hydroelectric power plants. Final energy form is electrical energy. So talk in terms of potential and kinetic. Mechanical, we have only learned potential and kinetic. So where is potential? The energy has to be stored in some form, no, before getting converted from that form to electrical energy. Potential energy of stored water in the dam, the height of the water. It is the water at the top which is held stationary there by the floodgates of the dam. So the top level layer of water has potential energy. Okay. Now that MGS gets converted into kinetic energy of the moving water. That hits the turbine blades. Okay. That develops now rotational kinetic energy. Right. So kinetic energy exists in various forms. Okay. Kinetic energy forms we did not discuss. Kinetic energy has got various forms depending upon nature of the motion. It is translational, okay, rotational, and vibrational. Depending upon what is the motion of the object, the kinetic energy will be named as translational, rotational, or vibrational. What is translational? When the object is moving in a straight line, like a bullet. Bullet will have only translational kinetic energy, right? Rotational kinetic energy. Can you think of any example of rotational kinetic energy? Fan. Okay. When the fan is rotating, it has rotational kinetic energy. Any vibrational kinetic energy? Engine of the machine. The piston movement is up and down. Okay, it's vibration. Okay. So, depending upon what is the nature of motion, the kinetic energy is named accordingly. So, in atom, like best case is atom. So, atoms in a gas. If you think of atoms in a gas, so they can have all kinds of motion. Atom moving from one position to other position, hitting the wall, changing the direction. Okay, that is translation. Then these atoms might be spinning also. While spinning, if it is diatomic, it might be vibrating and spinning like this. Okay, so all kinds of motion are possible in a gas. You get it? For you, or now, it's only translation. So I asked in hydropower plant. So stored water has potential energy. And water moves, hits the turbine, then it has translational kinetic energy. Turbine rotates, it has rotational kinetic energy. Then it rotates the generator, which produces electricity. What is the job of generator? To produce electricity. Yeah. So that theory will study in electricity. Okay. Right now, generator does conversion from rotational kinetic energy to electrical energy. Okay. So where is electrical energy in the room? Where is electrical energy in the room? Here, between these two holes. Okay. So you require potential difference. Which potential difference now? Electric potential difference. When you draw the current, those are charges in motion. The electric potential difference now is converted into kinetic. And it is due to kinetic, all the action, energy in action is kinetic. Yes, why is it used? Yeah, I saw those ones. Energy is very amusing. Yes, otherwise it will be dead. Okay. So electricity, when it is available in the socket, this one socket. Okay. Then it is electric potential energy. Unless you put a plug and switch on, that is still in the stored form. Okay. And when it is switched on, then it converts from potential to kinetic. Everywhere it is similar. Okay, just the nature of energy will change. Is that clear? So that's it. So for you, when the bow is released, okay. So when compressed spring is released, when the compressed spring is released, what happens? Tell me what happens. The elastic potential energy in the spring gets converted into kinetic energy of the ball. Remember that diagram? The elastic potential energy in the compressed spring is transferred as its. So there has to be some kind of interaction. Okay? Unless there is interaction between two bodies, the energy exchange will not take place. There has to be interaction. Any questions here? Okay, so I just gave you two examples. Likewise, when the stretched string of a bow is released, the potential energy of the stretched string will be transferred to the bow's arrow's kinetic energy. The one, what is moving? Arrow. So arrow will have kinetic energy. From where it got energy? From the stretched string when it was released. Okay? Yeah. All right. Now, those are Selena. They can read through this diagram. Okay, it explains you conversion of energy from one form to other form. Likewise, those who have brothers can look for conversion of energy from one form to other form. Okay? So what do you need to convert energy? We need a device. Okay? So during energy conversion process, what happens? Work is done. During energy conversion process, the device is working, and that's how it is converting energy. Like when fan is working, it is converting electrical to mechanical. How will you convert mechanical to electrical? Generating electricity. Okay? So this should be quite self-explanatory. Just spend some time. Here, which book here? No book. Read the volumes. What is given in the volume? Conversion of energy. So it's not given here. It is only given in your book. You just read through that diagram. It's not given here. It's in the book. So it should be easy for you to understand. Let's say, given page number. So just read this diagram. It will give you conversion from one form to other. This is very limited. Very limited. Read through your book. Okay. Let me ask you a question. How will you convert electrical energy into chemical energy? When you're charging a cell. What is cell? What is cell? It stores chemical energy. When you use cell, then you're drawing electric current. When the cell is in use, it is converting chemical energy into electrical energy. But when you're charging a cell, like mobile, when you're using a mobile, what are you doing? You're drawing current from the cell or the battery of the mobile. But when you're charging your mobile, that time you're putting electrical energy back into chemical energy. Okay? So used one way, look at the energy transformation. Used one way, the transformation is different than the other way. Got it? Charging is electrical to chemical. Using the mobile is chemical to electrical. Okay? So that is chemical to mechanical. Raise your hands who would like to answer. Give an example of energy transformation from chemical to mechanical. Huh? Done. Chemical to mechanical. That's chemical to heat. Give me some obvious example. That's not very obvious. Any engine, any automobile. Okay, any automobile. Let's say you burn petrol. Petrol is used in engine. That engine then rotates the wheel. Okay, so any automobile is a device which converts chemical energy into mechanical energy. Okay, so likewise you should. So you are provided with so many examples here. Some 17 examples are given in my book. Okay, so these are quite self-explanatory. Okay, give me one more example. Photo to electrical. What is photo? Light. Photo to electrical. Solar panel. Right? Directly converts light into electrical. Okay, that is photo. Chemical to light. Yes, you can say that. Chemical to light is or a candle. Chemical is very obviously when you're burning something. Candle. So when you light a candle, candle is burning, and that is producing heat and light. So just go through all the examples. You should be able to understand. Then the last topic here is degradation of energy. This degraded form of energy, that is unuseful. What is degraded or unuseful energy? Whenever energy is changing form from one form to the other form, it does not 100% converted ultimately the desired form. Some of it is wasted as heat. Okay, like when fan is running, 100% electrical energy is not converted into mechanical energy. It also gets heated up. Our objective was just mechanical energy, but some energy was lost as heat. That's first law. Yes. That's the ideal law, exactly law. Yes. So we'll come to it. Right now you understand, whenever the energy change is taking place, it does not happen 100%. That decides efficiency. That also decides efficiency. Because if the machine is using or wasting less power, then it is more efficient. Okay? That's how the cost of the machine is decided. All right. So do you see the star ratings in the ACs that you buy? Some are 5-star. Okay. More star means that is that much more efficient. It is wasting less energy. Is that clear? And also it is producing less of carbon. Okay. So whenever chain of energy takes place. Yeah, so you can't get rid of friction or dissipation, right? In the environment, right? You cannot get out dissipation free environment. Friction will always be available. That's nature. It limits us various things. So that is good also. I mean, if there was no friction, you will create unlimited energy. And if you do not know how to handle it, you will destroy the world. Nature puts limit on our activity, right? So this kind of these are checks and balances by nature, frictional forces. Imagine if there was no friction, will you be able to walk? So friction is also necessary, right? It will be slippery with the small. That is also necessary. Okay, so with this, our time is still 2:15. So the next topic is, we'll go to the next topic, which is conservation of energy. Last is conservation of energy. I think you must have learned it in your lower grades also. What is conservation of energy? Conserve energy. That's not, we're not talking about energy saving. We're talking about a fundamental law. Right now, the law of conservation of energy states that that energy can never be created nor be destroyed. It can only be converted from one form to the other form. Okay, that is law of conservation of energy. Right? So we have to verify this for two things. So the statement you can write from book. You can write the statement from the book, okay? So what I'm going to do here is verification of this is what we are going to learn. We'll verify law of conservation of energy for a really important topic. So let's see what we do here. So for this, consider an object of mass n falling from height h. This is what we are going to see. What do we have here? Let's do it here. This is A, this is E. This. Okay, so A, B, C are the different position. A is the top position of the body. So before falling, where was the body? It was at position B. Then the body was dropped. Right? So we will now see its energy. We will calculate its energy at various positions. And I will prove that its total mechanical energy was same throughout the fall. Okay? So let's see. So when it is falling, right? From here to here, it has fallen by x. Understand the scenario. From A to B, what is the fall? Displacement is x. So at position B, what was its height? H minus x. Isn't it? When the object has fallen from the top position to position B, it is fallen by distance x. At that time, what is its height? X minus x. Because total height was x. Okay. Now, tell me its energy. Of all these three positions, we now need to calculate its total mechanical energy. Right? Now at position A, what is its velocity? What is velocity at A? 0. At top position, what was the velocity? 0. So what will be kinetic energy? What is kinetic energy? Zero. Because at top position, its velocity is 0. Correct? What about its potential energy? mgh. Because maximum height, so mgh, what is total energy? 0 plus mgh. Correct? Now let's calculate its energy at B. Let us assume its velocity is Vv. Its velocity is Vv at B. So what is Vv? What is the relation between this and this? So while going from A to B, how much displacement is covered? X. What is the acceleration? G. So can you apply third equation? What is the third equation? Isn't it? What is the velocity Vb? By third equation of motion, Vb square minus Va square is equal to 2gx. होता है कि नहीं थर्ड इक्वेशन? क्या होता है थर्ड इक्वेशन? पंखा चला दो बेटा, पहले पंखा चलवाने और बंद करवाने आता है ना. थर्ड इक्वेशन ऑफ मोशन क्या है? पहला इक्वेशन क्या है? ऐसा होएगा यार, तुम बताओ. थर्ड इक्वेशन ऑफ मोशन क्या है? v स्क्वायर माइनस u स्क्वायर इज इक्वल टू 2as. सुना है? वही लगाए यहाँ. यहाँ पे क्या है? फाइनल वेलोसिटी v भी है ये दो पोजीशन के लिए. इनिशियल क्या था? va. डिस्प्लेसमेंट कितना है? s क्या है? x. और a क्या है? g. ये लग गया तो va तो 0 है, देखो vb स्क्वायर कितना आ गया? 2gx. ठीक है. काइनेटिक एनर्जी क्या होगा फिर? कितना होगा? हाफ m 2gx. तो 2 to कैंसिल. तो काइनेटिक एनर्जी b पे कितना है? What is the kinetic energy at position B? mgx. Okay. So what is the potential energy? It will be mg. Height कितना है? h minus x. हाइट कम हो गया ना इसका b का. ग्राउंड से लेते हैं ना हमेशा पोटेंशियल एनर्जी. तो हाइट कितना है यहाँ पे? h minus x. तो कितना हो गया ये? ठीक है. तो कंजर्वेशन क्या हो गया? When it travels from A to B, potential energy reduces by mgx and kinetic energy increases by mgx. तो यही तो कंजर्वेशन है. जितना पोटेंशियल रिड्यूस हुआ उतना काइनेटिक बढ़ गया. पहले काइनेटिक कितना था? 0. इनिशियली टोटल एनर्जी वाज इन द फॉर्म ऑफ पोटेंशियल एनर्जी, बट बीच में क्या हो गया? इसमें पोटेंशियल भी है और काइनेटिक भी है. बट पोटेंशियल कितना है? mgx कम हो गया. वही mgx कहाँ पे आ गया? काइनेटिक में. वो जो स्टोर्ड पोटेंशियल एनर्जी है, इट इज गेटिंग कन्वर्टेड इनटू काइनेटिक. दिस इज कंजर्वेशन. नाउ चेक व्हाट इज टोटल एनर्जी. काइनेटिक इज mgx प्लस mgh माइनस mgx. कितना आ गया? ये भी mgh. तो टोटल एनर्जी में चेंज हुआ? टोटल मैकेनिकल एनर्जी में चेंज हुआ क्या ए से बी पे जाने में? नहीं हुआ. तो यही स्टेटमेंट है. एनर्जी कैन नॉट बी क्रिएटेड नॉर इट कैन बी डिस्ट्रॉयड. इट कैन बी कन्वर्टेड फ्रॉम वन फॉर्म टू अदर फॉर्म. यही मीनिंग है कंजर्वेशन ऑफ एनर्जी. ठीक है. अब नीचे निकालो. तो नीचे क्या है? वैसे जैसे तुमने वीबी निकाला, लेट्स से द वेलोसिटी जस्ट बिफोर इट हिट्स द ग्राउंड इज वीसी. तो जैसे वीबी आया था वैसे वीसी स्क्वायर कितना आएगा? अभी जो x है वो पूरा क्या हो गया? h. जो x था वो क्या हो गया? पूरा h हो गया. तो ये 2gh हो जाए. 2gx की वजह क्या होगा? vc 2gh. तो फिर यहाँ पे हाफ m कितना आ जाएगा? mgh आ जाएगा. वही हाफ हाफ करके सब्स्टिट्यूट करो ना vc यहाँ पे. ठीक है. विल गेट दिस. अब यहाँ पे हाइट क्या है? c पे 0. ये क्या हो गया? 0. ठीक है. सिंस h इज 0 तो यहाँ पे 0 हो गया. तो अब जो पोटेंशियल एनर्जी टॉप में था वो टोटली किस में कन्वर्ट हो गया? काइनेटिक में. Potential energy at the top is totally converted into kinetic. So what is total energy now? ठीक है. So is the conservation of energy verified? For a freely floating object, total energy there is no change. So no energy created, not destroyed. What has happened in coming, in going from top to bottom? Potential at the top has been completely converted into kinetic at the bottom. यही है. ठीक है. एक क्वेश्चन आता है तो so verified law of conservation of energy for a freely flowing object. ये सब करके दिखा. देखो तो मैंने बताया वो कन्वीनियंट रहता है समझने के लिए. बुक में तो उसको अलग अलग पैराग्राफ्स में भी लिख सकते हो. दैट पोजीशन है काइनेटिक एनर्जी दिस, पोटेंशियल दिस, लाइकवाइज टोटल दिस. अरे पोजीशन के लिए तीनों एनर्जी निकालो. काइनेटिक, पोटेंशियल एंड टोटल एनर्जी. देन लास्ट में लिखो that hence it is verified that total energy remains same. So energy is not created, not destroyed, but it has changed form from potential at the top to kinetic at the bottom. पूरा potential convert हो गया. ठीक है. This is it. और एक और तुमको खाली एप्लीकेशन है पेंडुलम के केस में, so that will take up in the next class. ठीक है. पेंडुलम के केस में भी बता रहा है. What is the time now? So how was the understanding about the topics we covered today? Good? Is that a majority or everybody understood till the back? Till the back? Not an English teacher.